My name is Sanjeev, and this is a workflow that shows remote Dask execution on NERSC. This is part of the NESAP project. So the advantages of this, I could take a Jupyter notebook that's running locally on my machine, or let's say another HPC, and then with just using this workflow, I could have the compute actually run on NERSC. And I don't have to SSH into NERSC, I don't have to upload a script, I don't have to move a data set over. So this is useful for both automating like batch ML retraining or pretty much letting new users access like supercompute and just bring their own local code and have packages automatically sync and data sets. This workflow also supports the use of prefect, which lets you parallelize workflows with Python decorators, and then it gives you a control panel seen here that lets you track all the jobs running, which ones are successful, at what scale everything's running at. So this could be also useful for automated jobs and tracking sure that everything runs as scheduled. How this workflow works? Well, first off, I use Slurm via the SuperFacility API. That's just the API that lets me access like commands at NERSC, like job submit, upload file, read file. First thing Slurm does, it syncs the local Python packages that I have locally to my machine to a Con environment at NERSC. It uses a tool called UV that is a Rust-based Python package installer to sync everything. Next, Slurm allocates some compute and it starts a Dask cluster in there. Dask is a Python tool that starts a bunch of workers, and these workers talk to each other with TCP, and there's one worker that's a scheduler, and I could submit jobs to a Dask cluster. Dask creates a DAG and then parallelizes these runs, so I could store like terabytes of data in memory, and the memory split among these workers, and just lets me do computation at a large scale or like train batch machine learning jobs or different parts are running in parallel. So Slurm first submits a job, starts a Dask cluster, and then I need the local machine to connect to the Dask cluster. So after the Dask cluster starts, the workflow creates a SSH tunnel on the 2 ports that Dask uses and pretty much makes a connection from my local machine to NERSC to the login node that could access the Dask cluster. And then my local code could just point to a Dask client address as localhost 8786, and that connection is actually forwarded to the cluster at NERSC. All this could run in a few minutes, and then I could just go to my local notebook, click run, and it will run in parallel on NERSC. Here's a code walkthrough. Right here, this is the Slurm script, and it is setting up the Con environment, installing UV, and then starting Dask, the Dask scheduler first, and that's going to use a network interface called HSN0, which is faster, and then it uses a scheduler file to track the Dask IP, let the workers read what IP to connect the scheduler at. Next, we start the workers based off a scheduler file, and then it waits and checks how many workers get started, and then it prints out some information that it succeeded and lets the rest of the script run. But the script pretty much submits this job using the SuperFacility API and uses a key manager with a SSH key. The script pretty much uploads the requirements needed so the Slurm script could know what requirements there are, as shown there. And then the whole Slurm script is submitted and ran, and then every 10 seconds we pull for an updated status on this job, and based on the status we read the Slurm output file to see how far the Dask creation process is going, and then once we know it succeeded, we can open the SSH tunnel. So we're looking for certain keywords such as the host name, which is after all the workers have started. And if we get the host name and the Dask IP, then we know we have enough information to start the SSH tunnel, which is just using a subprocess command. Once it starts, it just waits for the user to close the tunnel, and you could just go to another script and run Dask locally. This is example prefect flow. Prefect is made up of flows and tasks. It takes your existing Python code and you just simply add decorators, and the tasks make up a flow. Prefect automatically determines what task could be executed in parallel and will create a DAG and run that in parallel, and it could execute on Dask. So it integrates into this workflow. Prefect also reports these workflows to a control panel, which I, in this case, have running at Slack on S3DF, logging all my jobs. Once the Dask cluster started, we could pull up this dashboard, which is being forwarded through the SSH tunnel. Here you can see the workers and their shared memory. When we send tasks, they come to here, and you can see the DAG graph. You could look at the overall system usage. You could inspect each worker, see individual memory, and the logs at each worker. Here we see the overall system usage. And then we could go to a local notebook. So this is code that's going to be running locally, talking via the SSH tunnel to the remote Dask cluster. And we could use all these workers' memory pulled together to store super large arrays and perform computations on these arrays. So here I'm just loading an array and summing up the array together. We could use features to call these compute functions lazily, and it's just way more compute than my local laptop would be able to do. When you go back to the dashboard, you could see that all these tasks ran and how they ran in parallel and when they ran. If we now go over to another local notebook, and this one's using prefect with a prefect workflow that's using the Dask cluster to execute. Prefect's useful because you could add decorators to existing workflows and it automatically creates a DAG and runs them in parallel. Here you can see that first we have to connect to the Dask cluster using the port SSH tunnel. And then from there we have a really basic test flow setup, and we set our prefect logging server to be the server running on Slack. And it creates a flow and runs it. And we could go over to this prefect logging server, which is running at Slack, and this is what we're using for digital twin modeling. And pretty much you can see that our flows did get logged. There, however, was a bug with package sync that we're working on, but you can see it tracks all the flows that have run and their outputs, and it's pretty useful for observability. There's the flow that just ran and failed. But at scale, this would be a good tool to monitor everything. The limitations of this workflow are first that you have to pre-allocate compute. I was experimenting with having Dask start each of its workers as Slurm jobs, but Slurm just gets bogged down and you have to wait for each worker to get queue time, and it doesn't work the best on NERSC. So I ended up allocating a node or two to this Dask cluster and then just let Dask workers run that compute. How it also works is we have SSH tunnels under the hood, and we have an SSH keys being used to authenticate the superfacility API. So each day you have to create new keys. And then the other thing is that you do need the same packages running locally and running in Dask and on the prefect server. So I managed to do that with a package sync using a combination of UV pip, which is a Rust-based pip installer, and custom conda environments. And this workflow now automatically will sync the packages. The other thing is that the whole connection, so transferring data sets and running Dask, is dependent on a SSH tunnel, which isn't the best approach. And you have to maintain this SSH connection the whole time you're running your local code. This workflow was originally created for digital twin modeling for LCLS at Slack National Lab. The idea there is each time the particle accelerator runs, we get new data, and we have to update machine learning models with this live data to keep the weights up to date. And we were looking for a way to take new data and offload it to NERSC instead of using Slack's S3DF, run the compute there, and store the data back. just because NERSC has more capacity. And this workflow can do that because it uses Dask connection to handle moving data sets back and forth, and it can store the results in the prefect monitor. In the future, we want to speed up the allocation, deallocation of compute. One example is Modal, and what they could do, you could just add decorators to your code, and your code just instantly runs in like the cloud using GPUs, and they have some way that like instantly allocates and deallocates compute, and you only pay for the compute you use. This is a little harder with NERSC, as we have to deal with Slurm and wait for the Slurm queue to go through to get compute and deallocate it and stop jobs quicker. This QR code goes to the GitHub if you want to check out the code, and feel free to send me an email.